I just want to point out a few things how to get your CEU documentation. It is really smooth and easy if you are an AFCEA member. So if you are, wonderful. You just get your badge scanned at the back of the room. Everybody needs to get their badge scanned at the back of the room before you leave at the end.
That's you.
Right,
she's the badge scanner.
Wonderful lady in the red shirt there. So she will be scanning your badges. Now, if you're not a member, it's a little more challenging to do that, to get the documentation. So I would encourage everybody, if you're not a member, please go to our membership desk. It ranges depending on your rank, depending on if you're a student, depending on if you're an individual. It's anywhere from $15 to $50 and wonderful resources. So I would encourage you to do that. It's just so much easier to get your documentation for the CEUs. Okay. So I'm very happy to introduce Michael South from Amazon Web Services. He is going to be talking with you for the next hour, hour and a half. And Michael was a commander in the Navy for about 25 years before going to AWS in 2017. He's going to tell you a little bit about himself and about his topic today. So thank you again for joining us. And I just want to...
No. Thank you, Mary.
Okay.
I appreciate it. It's an honor to be here this morning. One, to be back supporting the DoD. I love to come back and support the DoD. I kind of feel like I'm at home, and especially the week after Veterans Day. So thank you very much for having me here today. As Mary said, I've 25 years in the Navy, and so I'm kind of walk you through a little bit about my background and kind of my journey to the cloud and how that will probably correlate to what a lot of you may experience as you move to the cloud or start considering that. And we'll start going over some of the capabilities, some of the challenges from an on-prem environment and moving to the cloud, some of the capabilities and benefits. So within the Navy, 10 years enlisted, 15 as an officer. I've ran the data centers and networks in Europe. I was the CIO for Japan, the 7th Fleet IAM. So I had a lot of different jobs within the Navy, right? So I've done just about everything, from the old help desk when I was enlisted all the way up to managing the large enterprise networks, shipboard networks as well. In that time, I had a lot of challenges, as we all have, right? I mean, Spayware delivers some great products to us, but IT is just a very challenging environment, especially in an onboard environment. And when I left the Navy, I went to the city of D.C. as a deputy CISO for the city government. So some of you from this AOR may know Captain John McMichael, or affectionately known as Johnny Mac. He was the CEO of NICTAM's PAC a few years ago. So he was the first CISO for the city of D.C., and he hired me as his deputy. And so I saw a lot of the same challenges there in D.C. as I saw in the Navy, right? IT is not really something so unique to the DoD and the challenges that we would experience in the DoD. Some of those were... It never seemed to amaze me that we would lose sight of a server at some point in time, right? Some server would pop up, has some old operating system on it. It wasn't on our list of upgrades or transitions. Maybe it hadn't been patched in a while. It could be for a variety of reasons, right? It might have been put off to some network segment for security, but then our security tools didn't have access to that network segment, or somebody changed something, right, and we lost access. The endpoint protection might have either not have been installed, malfunctioned, stopped reporting up, right? But we would lose visibility into our assets, which kind of counters that traditional mindset that when we have that physical control, that physical access, that it actually equals visibility and control, when it really doesn't in today's cyber world, right? And we see that all the time. So we would experience challenges like that from visibility. We would have challenges with resiliency, right? So in the DoD, we have mission-critical applications, right? And we have data centers all over the world. But it's a very big challenge to try to get those critical applications so that if we lose a data center, we don't actually lose that application. Oftentimes, we spend a lot of our time and focus on disaster recovery, or COOP, right? Continuity of operations plans. And so there's a lot of time spent on that very reactive DR strategy, right? Making sure we have data offsite in another data center. We have the capacity to spin up servers, restore from backups, which we all know goes perfect every time, right? But it was a big challenge to try to get resiliency, which is that proactive component to focus on rather than that reactive DR strategy, right? So very few applications, in my experience, and things could have changed since then, within the Navy and then within DC, where we actually had applications that were spread across multiple data centers, right? So that if we lost a data center, it would still be up and completely up and operational. Another thing is defense in depth. So we've been talking about defense in depth my entire career, right? But that's not the reality. And I'll go into a little bit more of that later. And then a low degree of automation, right? We have a lot of people spending a lot of time on very manual tasks, right? It is very difficult when you, in an on-prem environment, when you have multiple different technologies from vendors, and to be able to automate a process across all of them, okay? You can automate processes within a particular product type or family, but it's very difficult to automate across all of them, right? So we spend a lot of time on very manual processes, right? And so as in my journey, not really doing anything with the cloud and the Navy, but then when I got to the city of DC, the city of DC was already starting to move to the cloud. The DC Healthcare Exchange was already going into AWS. From the technical geek in me, I was very excited about the cloud, right? I was like, this is fantastic, I want to learn more. But from a security professional, well, this was actually my job, it terrified me, right? The first thing I thought about is what we see from a lot of our customers. Wait a minute, I don't know where my data is at, right? It's in this mystical thing called the cloud. I have no idea where it's at. I have no control over it. I have no visibility. And how am I going to secure that, right? How am I going to meet compliance if you have any type of compliance requirement, right? So if you're at a hospital, whether civilian or DoD, you have to meet HIPAA compliance, right? In the DoD, you have to meet the DoD SRG and FedRAMP compliance, right? How do you achieve that? How do you maintain it and monitor it? And so those were all challenges that I had. And as I was going through my journey in DC, came to find out these all became benefits of the cloud. Now, I will say I made a mistake. I first tasked my team in DC. I tasked them to look at the cloud, look at your particular role and the processes that you are responsible for, and try to figure out how you can do the same, how you can achieve the same results doing things the same way in the cloud. Right? Looking back, that was a limiting task. I should never have said doing things the same way. I should have just kept it as, can you achieve the same results in the cloud, period, and let them kind of see where they find themselves. Now, it didn't take long for everybody to realize that, yes, they could achieve the same results in the cloud that they do on-prem, doing things the same way, right? You can scan your servers in the cloud just like you can scan them on-prem. You can patch them. You can implement firewall rules. You can manage your identity and access management, right? So it didn't take long for them to figure that out. However, we didn't stop there. We kept trying. Every time we learned something new, we learned a little bit of a how. And that how translated into, oh, wait a minute, we can do something a little bit different here. Wait a minute, when we do something a little bit different, we actually gained a benefit. It actually improved our security, improved our processes, right? Which in the end started improving our security. So I'm going to start with visibility first. Again, going back to that traditional mindset where that physical control equals security, right? Again, the challenge that we see, the reality that we see is that's not necessarily the case, right? Previously, when you had 10 servers in a rack and you can go up and touch 10 servers, you knew you had 10 servers, right? They were either on or off, connected or not, but you knew you had 10 servers. Now, those 10 servers could each have 10 or more virtual servers on them, right? So now that physical access, that physical visibility doesn't equal logical visibility, right? And in the cyber world, that logical visibility is significantly more important, right? It doesn't matter where your server sits at. If it's vulnerable, somebody from around the world is going to hit it, right? So that physical aspect needs to kind of overcome. We challenge ourselves, we challenge our customers to kind of get over that a little bit and start thinking from logical visibility. And so with the cloud, there's a lot of services that really help with visibility. I'm going to go over a couple that we have, but really there's some commonality across cloud service providers. And so it's a matter of just trying to understand what each one has and what capabilities it brings to you. So we have CloudTrail. CloudTrail logs all your API activity. within our infrastructure, everything is done through APIs. So whether you go to the web console, make a click, whether your developer does a command line interface CLI command, or whether you're using APIs, it all gets converted to APIs. So everything within your architecture is tracked via an API. Okay, who did it? What time? When? What services? What were the actions? Right. So now you actually have, through this homogeneous environment, true logging across your infrastructure, right? On-prem, you have each of your devices or disparate technologies logging, right? And you may even have a log service that's collecting it all, maybe going into a SIEM. But now the infrastructure itself, right, is doing it all for you. Because what happens if you have a device that stops sending the logs over to your log service or your SIEM, right? You now have lost that visibility, right? But with this, it's now maintained for you consistently through your entire environment. You don't have to worry about a logging service stopping, okay, or a component falling offline. You're going to have all of those logs. The Virtual Private Cloud flow logs, or VPC flow logs, tracks all of the network activity going in and outside of your environment, okay? So now you have the network activity as well as all the command and activity within your environment. CloudWatch is, I equate to similar to an on-prem SIEM, but it doesn't do all the correlation. It tracks all your events, it'll alert on events, but it doesn't have all the advanced correlation that you might see in a SIEM. We have our web application firewall, so you can see what's being allowed access or denied access to your web applications. And we have Inspector, which is very similar to Nexpose or Nessus, and then it runs a vulnerability assessment across your servers. Something new with Inspector, though, is that they actually have an agentless-based network vulnerability tool now, where you can actually see what servers are accessible from the internet, right? And so that's something that some of the other network scanners can't really do because they're looking at only the OS. This is looking at the OS as well as the connectivity to the internet. Okay. Now, all of that's very similar to what you would see in an on-prem environment, right? Nothing new, some new names, a couple, maybe a little bit different hows, but very similar. But what changes, again, in that homogeneous environment is now with all of that data that you have across your infrastructure in one place, we have tools using artificial intelligence and machine learning to start taking a look at your environment through automation and telling you when it sees a potential problem. So one is Trusted Advisor. Trusted Advisor looks for best practices. Looks for best practices in security, looks for best practices in optimization, okay? And this is where it really starts helping you say, oh, you have some storage that's been made available to the public internet. Now, if that's servicing a public website and it's just public data, then you're right, that's fine, that's what we want. But if that's sensitive data and somebody went in and opened it by mistake, then it'll alert you to that. Okay. Now, with that said, we actually have governance options to actually prevent that from happening. All right. So when you read in the news that somebody's Amazon S3 or search service, which is our object store, was open to the public and it had sensitive data on it, somebody chose to open that. All right. It's actually closed down by default. We have Macy, which is an intelligent, think of a data loss protection or DLP solution. Most DLP solutions sit at the perimeter, right? And they're looking at data that's leaving your network. And it's looking for sensitive data, PII, credit card numbers, or anything that's with a keyword or tag. And it either stops that data from leaving your network, okay, or it'll let it go and then it alerts you. Macy actually looks across your storage, okay, and it identifies sensitive data within your environment before it's ever accessed or leaves, right? So you know where your credit card numbers are, where your social security numbers are, where your encryption keys are within your environment, all right? Now, in my experience, shared drives are a disaster, right? You never know what's on a shared drive. Somebody put a file up there and you're just hoping that nothing bad ever happens from it, right? Because it's very hard to track that. Macy helps you discover that where it's at, right? It also has rules. So if you have a rule that says all credit card numbers or social security numbers must be encrypted, and it finds those in a file, say an Excel file or PDF, it'll actually go through and encrypt that file or encrypt the entire bucket, depending on what you select. It also starts looking at your behavior analytics. Okay, who's accessing what type of data, when they're accessing it, from where. And so as it starts learning the normal routine and business of that data, it'll start alerting on anomalies for access based off of behaviors. All right, so this is something also you don't normally see in an on-prem environment, whether it's a shared drive or even a database where you're looking at that behavioral aspect of access. It also looks for compromised IAM accounts. Artifact is not really a technical service in that it actually does anything technical, but it provides you all of our third-party audit reports. This is something that's very important. As you start moving to the cloud, all right, you want to ensure that the cloud service providers that we're actually doing what we say we do. Okay? The third-party audit reports provide that detail to you under NDA of what we're doing and that we meet the security controls satisfactorily. Right? Previously, if, I don't want this to come across the wrong way, but if you had a particular military component that was running a data center or network, and you were in charge of an application on that network, right? You would have an MOA or an MOU between the two, but how do you know that the organization that's actually running the data center, running the network, is doing everything they're supposed to do to secure that, right? You don't. There's a trust. Now, within the DoD, there's a lot of trust within the DoD, but in a commercial world or outside the DoD, there's not that much trust. And so this is how we prove to you that we actually are doing what we say we do and meeting those controls. This is how you're able to inherit our controls for your packages, right? So if you're going to do a risk management framework or RMF package to get an ATO, in the cloud it's going to go through the FedRAMP process, which is just a cloud version of the RMF. But that's how you're going to inherit our controls. Okay, that's how you're going to have that granularity to know what was done and be able to bring that into your package, your system security package, all right, for your ATO. And then guard duty is intelligent threat detection, which I'm going to go over a little bit later. So these are specific security services that provide visibility. Okay. In addition to this, all your other services that are either providing compute or storage or whatever it's providing to you, they all have a means to provide visibility into what they're doing as well, what assets you have, okay? And because of the fact that we provide these services to you, like on the compute side, it doesn't even matter if a server's turned on or off, right? You're going to know that server is there. In my past, we were using Hyper-V for some of our virtual servers, VMware for some. We might have an Oracle stack. So in order for me to actually get a full inventory of all of our servers, I'd have to pull the inventory from all three platforms, right? I'd have to try to compare that to our endpoint protection or HBSS, right, for the DoD. I'd have to look at my network management tool to see across the network to be able to pull all that. Now, I have it all in one shot, all right? It doesn't matter if it's turned on or off, what network segment it's on, I have that visibility. Any questions on visibility? All right, moving to resiliency. Now, cloud service providers, we use some of the same terminology, all right? Unfortunately, they all don't mean the same thing. So as you're evaluating a cloud service provider, it's very important for you to ask the questions about what do some of these terms mean to them, all right, and how their infrastructure really is built. For us, it's 18 regions, 55 availability zones, and 121 edge locations. And actually, as of yesterday, it's 19 regions. We just launched US GovCloud East yesterday. Okay. The availability zones, the numbers in the circles and the numbers in parentheses are the number of availability zones. I'm going to get to that in just a minute. All right, so why is this important? For us, a region, actually, I take it back. It's actually 21. So we also have our secret region for DoD IL6, and we have our top secret region, okay? So we can support whatever classification you need in the cloud, we can support, all right? So our TS is connected to JWICS, secret connected to SIPR, okay? We have GovCloud for FedRAMP High, and we have our US East and West for FedRAMP Moderate, okay? And so now with US East, it's actually 21. I didn't know that was going to happen until I got the email last night. So what does a region mean for us? A region for us is comprised of 2 or more availability zones. The new standard is 3 availability zones. An availability zone is a logical fault isolation zone, okay? It is comprised of at least one data center per AZ, but oftentimes there are more, okay? What this means is that when we're doing maintenance on our services, we do our maintenance per availability zone, okay? And especially when we have multiple data centers within an availability zone, we'll do one data center at a time, all right? So this prevents a widespread outage, all right, across the board. I'm sure everybody here is familiar with the ASI process, right? Every weekend you got to take down servers or something's not available for patching, whatever the case is. This allows you to not have to deal with that anymore. And I'm going to get to that in a minute. But it also means that if we do have a service outage, not maintenance, it also limits the scope of impact to an availability zone. It allows you to schedule your maintenance for an availability zone. Or if there's an outage, again, it's only limited to that. All of our data centers are on low-risk floodplains with multiple different ISPs coming in with physical diversity, multiple power sources coming in with physical diversity. So very similar to the DoD. We also have very low latency links between our data centers. So you can actually achieve synchronous data replication within the region. Right? That's very, very important, especially when you're looking at high availability to keep applications up and load balanced all the time. So why is this important to understand? One, because now you can start to see how we're shifting the focus from a reactive DR strategy to a proactive resiliency strategy, right? You are mitigating the risk on the front end rather than hoping the back end will work, right? Not to say DR is going to go away, but you're shifting the risk or the mitigation of that risk to the front end, okay? That's very, very important. But why is this really important to understand for each CSP? Some cloud service providers, one region is one data center, right? So if they lose that one data center, they lost their entire region. Or they might have two data centers, but they're in the same building, one on floor 1, one on floor 2, okay? So it's very important when you're looking at cloud service providers to ask the questions for the regions you're looking at going into, what does the architecture really mean, okay? Because you're going to want, I would suspect, especially for the critical, you're going to want them into physically separate facilities, right? All right. I talked a little bit about this already. So on US and East and West, you have your public-private data, unclassed, FOU, PII, PHI, FTI, for FedRAMP Moderate and IL2. Now, I know for the DoD, PII is IL4, so I get that. But for the rest of the world, PII is FedRAMP Moderate. We have GovCloud for CUI, ITAR, CGI, FedRAMP High, and IL4 and IL5. We have our secret, top secret. All the personnel managing the data centers or the services in those regions are cleared U.S. personnel. Okay. All right, so that's great that we have this infrastructure, but what does it mean for you? How do you actually take advantage of it, right? Because if you have a server stack now, say you have a 3-tier web app, a web server, an app server, and a database server, and you move those 3 servers to the cloud, right? You still only have 3 servers. If they go into the same data center, you lose the data center, you still lose your application, right? So what value did you really get? What changes is how you architect. In this example, I just put a firewall as your perimeter, right? You're going to have a lot more capabilities besides just a firewall probably at your perimeter. But you're going to have a load balancer. This is typically a physical device, right? You might have a couple devices that are logically connected so they can take over for each other. But there's still going to be a limit, between that. You're going to have maybe a couple web servers, an app server, a database primary, and a database secondary, right? This is typically all in one data center. If that load balancer fails, your whole application's gone, right? If the firewall fails, unless you have it fail open, which we probably don't, you've lost your entire application, okay? So now we start shifting to the cloud. So you're going to go to the cloud. You're going to pick your region. Another thing with us is that the region, all your data that you put into a region stays in that region, okay? We do not copy, backup, or move your data out of the region you select for any reason at any time, okay? Now, that's another important factor because remember when I told you about some CSPs where it's just one data center? For them to meet their service level agreement with you, they actually have to back up your data to other regions, right? So that it's available in case they lose that data center. Right? This is where they may not share that visibility with you or give you any type of control of where that data may go. All right? But because of our infrastructure, we're able to do that all within the region. All right. So now you're going to create your virtual private cloud. This is the security boundary around your application. You're going to pick at least 2 availability zones. US East has 6 availability zones, so you can actually spread your application across 6 different, say, data centers within US East, okay? But we're going to pick 2 for here. Then you're going to have your subnets. You're going to have your public subnet or your DMZ subnet where the web servers are going to go, your application subnet, and your DB subnet. In my experience, a lot of times within a data center, even within a full data center across applications, they're all sitting on a domain, right? Oftentimes there's no security or control between the connectivity or communications across servers within a data center, okay? So granted, the application will direct traffic through the application process, but there's nothing stopping from a server in application A from talking to server in application B, unless they're actually network segmented or somebody did specifically break that off, right? But it can be very expensive if you're going to actually put firewalls or network segmentation across all your applications within a data center. But now we're actually doing the subnets around each tier. Oh. And we have our Elastic Load Balancers. These are virtual load balancers. They're sitting on thousands of servers. All right? It's not one device that if it fails, you lose your application. Right? They're spread across all our data centers. So even if we lose an entire data center, or more than one data center, that Elastic Load Balancer is still going to stay up and operational, providing that load balancing service to your application across the AZs. Okay? In addition, we have the one on top, okay, coming in from the internet, but we also have one between tiers. So now, your web servers, when they come in, right, in this model over here, if we did have 2 app servers, what would happen is if this app server down here died, if one of them died, this whole line would die. You'd lose half the capability of your application, right? Only the other half would stay up and operational. Now, you have a load balancer between the 2 tiers. So if any particular server dies, crashes, gets taken out, the data center is gone, you still have that load balancing providing. So your application is still up and running. Okay? The next is we have the auto scaling groups. This is something that really is pivotal to what the cloud is. So we call it hyperscale cloud services, right? The cloud, there's a lot of mystique around the cloud, right? So unless, and what it is and what it's not. The cloud is not just your data in somebody else's data center, okay? That is a huge myth that people just have this thing that it's hard for them to comprehend the fundamental difference in what a hyperscale cloud provider does and what a colo facility does, okay? Now, we're seeing a lot of rebranding of colo facilities to private cloud, right? But that really is just your server in somebody else's data center. This right here, this auto scaling, along with the Elastic Load Balancing and a lot of other services, is what really makes a difference. For example, if you are a university, okay, and you have a course registration application, right? Most of the year, that application is not really being used. You have some administrative staff that's maintaining the information on the courses, okay? And so the servers really aren't being utilized that much, right? And then 2 or 3 times a year, you open up the registration, and thousands of students start registering for class, all right? Now the servers are being bombarded. This means that you have to buy very large, powerful, expensive servers to handle that peak load, which is only 2 or 3 times a year. Okay? That is, one, you consider it a waste of money because you're not getting value of those servers for the majority of its life cycle, right? If you underestimate your capacity needs or they grow, right, you're out there procuring more, right? And in the DoD, procurement can be long and drawn out. Auto-scaling will allow you to move those very large servers over to the cloud, but instead of moving large servers, They're actually just 2 small servers now, 2 small web servers, right? Just what's needed to handle that day-to-day load for the admin staff, okay? You can set parameters on to when the resource utilization goes up to a certain level, that new images start being spun up. New servers get spun up next to it. They start taking that load, right? So now you're only going to have servers up and running when they actually have the load required for them, which means you're only paying for those servers when they're actually up and operating in use, okay? Registration shuts down. The students all have their classes. The autoscaling group sees that those web servers are no longer being utilized. It starts shutting them down. You're no longer paying for them anymore. Okay? This also allows you to shift from treating your servers like pets, right, to treating them like a commodity. Right now, your servers are pets. You name them. You go in and pet them every day. If one dies, you cry. It's a very, very bad day, right? Now, if you have a server that dies, gets blue screen of death, it gets attacked, whatever, it doesn't matter. It shuts off. A new one replaces it immediately, okay? So now, you don't really care anymore if a server dies, right? You got one to replace it like that. Your application stays up and operational, okay? Now, on the bottom, we have databases that are, say, you manage them, right? You install the operating system, you patch it, you configure it, you install the database service, say it's a Microsoft SQL Server, Oracle, whatever it may be. You maintain it, plus you maintain your database and the data, right? You can also shift, the icons are the auto-scaling servers. You can also shift to managed services. So now, you don't have to worry about installing, configuring, or patching the operating system or the database application. You only need to worry about your database and the data itself, right? My experience, patching applications with database servers was the biggest challenge, right? The application owner would always be like, no, you can't. We don't know what's going to happen. It's going to crash our system. That was always very challenging, right? Now we take care of all of that for you, all right? And through encryption, all right, I'm going to get into that a little bit later, but through encryption, we don't have access to your data, right? So we maintain that platform. You maintain the database and the data. We don't have access to it, okay? Any questions on this? All right. So this is how you achieve high availability in the cloud, right? This is how you move to a proactive resiliency model in the cloud. No more ASIs, no more worrying about, a hurricane taking out a data center. You're going to have everything up and operational. Our service level availability is 99.99% for services. For S3, our object storage, it's 11 nines of durability, right? 99 point and another 9 nines going out for durability. And we can achieve that because of this infrastructure in each region. All right, moving to defense in depth, right? Highlighted that we've been talking about it for decades. I swear there's a DoD manual talking about defense in depth in the late 80s, maybe early 90s. This is the reality, right? We have a lot of security products on the perimeter, and really that's where the depth is that shallow depth at the perimeter. We started endpoint protection. Well, we've had antivirus forever, but we started, endpoint protection, 10 years ago or so? So we focus on the perimeter, we focus on the endpoint, but it's still soft and gooey in the middle, right? Admins once they're an admin, have access to probably applications and data they really shouldn't have, right? Once you're inside the network, you can travel pretty much anywhere inside the network for the most part, right? Why is that? Again, because it's very expensive, right? If you wanted to put in a bunch of Cisco ASI firewalls in between every single server or every application, that's extremely expensive. Not to mention the manning required to take care of that, right? So now, this is where you can start achieving what I call true defense in depth in the cloud. I'm going to highlight how this would work, okay? So, again, in your data center, really, once you're in the data center, it's kind of wide open for the most part, okay? I know there's some differences, but for the most part, it's kind of wide open. Now, the VPC is that security boundary around each application. All right, so right off the bat, you have a security boundary around your application. You have your subnets protecting between the tiers. So when you add your ACLs, the VPC in your subnets is the equivalent of a stateless firewall, okay? We have direct connect, which is private fiber between you and us. So now you have basically an extension of your network into the VPC. It is not an extension of your network into all AWS infrastructure, right? It doesn't mean that all of AWS is now inside your network. It is a private fiber just between you and your VPC, okay? We also have a VPN Gateway. Oftentimes, if you're developers, you might be using that to get into the infrastructure doing the development work. We have our Internet Gateway. This is really important. By default, a VPC has no access to the Internet. If you start creating an application, putting data into your VPC, it does not have any access to the public Internet. You're only able to access those resources through your console, log in with your account, or through Direct Connect or a VPN. Okay? We also have Shield. By default, everybody gets DDoS protection for free. Right? That's something you don't get in an on-prem environment. You're going to be paying for that to another vendor. We also have Shield Advanced, which is a paid product, but Shield is still, by itself, is a great DDoS protection by itself. You have a web application firewall, very similar to your normal on-prem environment. We also have phenomenal partners that help provide more capability than some of our services, right? So our WAF is a good WAF. It helps protect against SQL injections and cross-site scripting. But if you're familiar with a particular product on-prem and you want to try to achieve that magical single pane of glass where they can manage their on-prem devices as well as their cloud devices, you can select one of our partners. They also have a lot more features than some of our services have. And then GuardDuty, which again is our signature and behavior-based intrusion detection. I'm going to go into that again a little bit later. So other than maybe the DDoS protection, which you could still pay for an on-prem environment, all of this, other than GuardDuty, is pretty much similar to what you see now at the perimeter, right? Nothing too new, okay? When you start talking about VPCs, where, again, the VPC is that security boundary around your application, this starts changing, right? So now before, where you kind of have them, they're all open within a data center, by default, there's no communication between VPCs. Whether you own them or somebody else owns them, there's no communication between VPCs. Now you can create an internet gateway with a VPN, and at the application layer, they can communicate with each other if they need to. You can establish a private link. So if you have a VPC that's kind of a services architecture, right, a shared services architecture, and you need other applications to be able to communicate and get some information from that, you can have a private link. Or you can do VPC peering, which is basically a network connectivity between your VPCs. Again, though, with the ACLs, you're able to limit what servers are communicating, what ports, how they're communicating, and so forth. All right, so that's a little bit different. But this is where the money's at. The security groups. The security group you put around each tier. A security group is the equivalent of a stateful firewall. So now you have stateless firewalls around your application and between your applications, okay, and between the tiers. And now you have stateful firewalls between the tiers, okay. Now you would think, okay, well, that's great, but now I have thousands of firewalls rules that I got to worry about. You can implement a standard governance across all of your VPCs, okay, all of your accounts, and you can automate updates, management, responses within that, right? So it's not going to take an army of firewall engineers to manage all the new firewall capabilities that you now have. You still have third-party endpoint that you can put on, right? So within your servers, your virtual servers, you can still put on HBSS. You can have it reporting to an EPO server in the cloud, or you can have it reporting to an EPO server on-prem. Inspector, which I talked about, again, that vulnerability scanning service, but also has that ability to detect what servers actually have access to the internet, right, or accessible from the internet. Systems Manager, you're probably familiar with, like, say, Microsoft Office or Microsoft Operations Management Server, where it helps you just kind of keep track of all your virtual servers. It can push patches, helps you keep the inventory of them. CloudTrail for logging, CloudWatch I talked about for event management, and then guard duty. So now, this is where you're actually able to achieve that true defense in depth, right? We have it at the perimeter. You have it between applications. You have it within the tiers of an application. And actually, one thing I meant to highlight was as those servers spin up, so if you have a web server and new servers spin up to handle the load, or you have a couple servers in a tier, by default, they cannot communicate with each other, right? If you have one web server talking to another web server, it's been compromised, and they're trying to move over to the other web server, right? Should never happen, which is why we also don't want a web server talking directly to a database server, right? That should never happen. The web server's been compromised, and they're going straight after the data, right? This is why it's very important to have this defense in depth within the tiers of an application, right? When too often that application is considered one security boundary and everything within it is allowed, right? And the problem is if anything is compromised, they now have access to everything, okay? Any questions on, actually, before I move on, the last part of the defense in depth, which I don't have a slide for, is really the data, right? Our CTO has a saying, dance like nobody is watching, encrypt like everybody's watching. If it's not public data, encrypt it, right? Just flat out encrypt it. So encrypt your data at rest, encrypt it in the databases, encrypt it in transit, encrypt it everywhere. So now, with all of the infrastructure components that I just talked about, and then encryption, and then, of course, your access controls, you're able to get that true defense in depth from the perimeter all the way down to the data itself. Any questions? Okay. Automation. This is one of the things that I found was one of the biggest benefits when I started looking at moving to the cloud. You might have a SOC, or a Security Operations Center, all right? Within that, there's usually analysts tier 1 through tier 4. In my experience, a tier 1 analyst are somebody who's straight out of school, no experience, super intelligent, super motivated, right? And what do? We give them a checklist. Don't think, follow the checklist, right? What a waste of human resources, right? Who has enough people for everything that they need to do, especially in security? I have never seen a hand go up for that, right? But yet we're wasting so much of our human capital on manual processes, right, that really doesn't require brain power. And so automation is key in the cloud. Our CISO, Steve Schmidt, made a mandate 2 years ago to reduce human access to data by 80% year over year, right? He knew that if he just said 10%, a service team would say, hey, Bob, I'm going to take away your credentials. You can still develop, you can do everything, but when it comes to the deploy, you're going to pass it over to Mary over here. She's going to go deploy. So he drove an 80% reduction in human access for 2 reasons. One, to be a catalyst for change, right? To force people to rethink how they do their job, to drive new innovative processes and concepts. 2, because of the fact that, look at our global infrastructure. I know how many people I had working for me in the Navy managing a data center or a network, right? I will tell you that the number of people we have with privileged access is significantly less than one particular service here today, right? And we're able to achieve that through automation. We also saw, just like what I saw in my experience prior to AWS, is, people make mistakes, right? Doesn't have to be malicious, but people make mistakes. And then, of course, today you have the insider threat, right? The malicious insider threat. And so we have this 80% reduction year over year. So this is some of how we do it. Guard duty. I've been punting this one for a little while. Guard duty is kind of the heart of our security automation. Everything in white, and I apologize if you can't see it in the back, are threats that are stateless findings or stateless threats that guard duty can detect. So your port scans, your brute force attack, Tor API call, CNC activity, everything in blue is your stateful threats or findings or behavioral. So you have malicious comms, you have your Bitcoin mining. We had a commercial customer who was running their production Microsoft Exchange servers in AWS. And they had a couple IT folks that thought they were going to make some money off of this, right? So Exchange servers typically run hot, right? They're always high utilization. And so a couple of the IT staff decided to install Bitcoin mining software on these servers, thinking that the normal exchange activity would disguise the Bitcoin mining activity. As soon as they turned on guard duty, detected that activity, they were able to identify the servers, remove them from the servers, and because of all the logging, they knew exactly who and when did it, so they were able to take care of that organizationally. I will tell you, in my experience, if you would ask me any given day who accessed what server with privileged credentials and what they did, I wouldn't be able to tell you. Right? I'd probably have to task one of my staff to go pull up the event logs and hope that they're working and they're not full and they weren't covered up or deleted, but it'd be hard for me to prove that, right? Now you're actually able to prove that. So guard duty, you enable it across your accounts. We use third-party threat intelligence from Proofpoint and CrowdStrike, plus threat intelligence we discover and build from managing our global infrastructure. It looks at all your logs, your DNS logs, your VPC flow logs, your API logs, and it is able to detect all of this activity. Okay? It also has machine learning, so it's constantly learning your environment. Okay? Now, one of the things it'll detect, and so this is kind of benign a little bit, or may appear to be benign. When you put a web server online, one of the first things that happen is it starts getting scanned, right? Google's scanning it to add to their search engine. Somebody who's just playing around on the internet finds it, starts scanning it. You might have a cyber criminal, you might have a nation state start scanning it, right? So if you have a security analyst and they're seeing basically all these different type of scans going across this web server, how do they know which one is the real threat, right? Very, very difficult to identify that. So they might just go first in, first out, right? First one pops up, okay, I'm going to research that. Okay, no, it's Google, we're fine, right? And then how do you, if it is something malicious, okay, what do I do about it? How do I really know? So in this case, you can use guard duty and you can automate. So in this example, say there's an IP address that's a known malicious IP address, right? This IP address has done bad things on the internet elsewhere, right? It's coming from a country we're not overly friendly with, okay? Now we have some context, right? So now the analyst has some context. So as they're looking at all these scan alerts, they can kind of decide, wait a minute, this one's a little bit more concerning to me, right? Now, if they see it, right, and they see it soon, and they do the research, by the time they implement any type of protection, at best you're talking half an hour, more likely hours, days, weeks, okay? Now, through automation, guard duty will pick up that IP, send it to CloudWatch, right? So all your events are at. It'll create a CloudWatch event. Lambda is a serverless function service. So think of it as just functions or commands or scripts sitting out there ready for something to trigger them. Okay? You don't have to manage a server. You don't have to install, patch, or do anything. They're just commands waiting to go. As soon as this event occurs, we have a malicious IP address coming from X country. Well, right? Country orange is what we use, right? Coming from country orange, it'll pick up that IP address and it'll pop it into the WAF. Or this is one thing you can do with it, right? So now, within a couple of seconds of detection, right, you have now mitigated that threat. That IP address is no longer able to continue its scan of that server. It also stops the IP from scanning any other server behind your WAF. All right? So now within seconds, you've mitigated the threat. Okay? Now, if you need to, you can add human stop gates, right? You can have all the automation come up to this point, and then the SOC analyst presented with a choice. Do you want to add it to the WAF? Do you want to add the IP address to an ACL? Do you want to ignore it? What do you want to do with it, right? And then you can have the SOC analyst actually use brain power, right, and make a choice, and then it'll continue on with whatever the choice was. But in addition to that, you can have it do other things. You can send it to third-party tools, firewalls, your configuration management tool, whatever the case is, whatever you wanted to do, you can have it do multiple activities. You can send an SMS, text, email, okay? So now you have all this automation, right? So now you actually have the ability to have your people focus on people problems, things that really need brain power. I'm not going to go over all these. These are our security services. One note, our key management service is FIPS 140-2 compliant, okay? And it's nicely integrated with all of our services. So you can use that for key management for your encryption across storage, databases, and so forth. Initially, we would see, these are all the types of workloads that are good for the cloud. Essentially, almost everything. We used to see web applications and websites being the first thing moving to the cloud. Right? They're low risk, they're public data generally. It gives the customer time to start thinking and learning about what the cloud is and how to work it. But we also saw that was from organizations that really didn't have a nice integration with the security teams. Right? So what would happen is they would move their web applications, maybe a backup recovery or disaster recovery, but as soon as they want to do anything else, especially your mission critical applications or enterprise, security would get in the way. Right? Because they were not brought on board at the beginning. They came late to the game. They're no longer part of the solution, right? If they were like me, they were terrified of the cloud because they had never worked with it before, right? And it becomes a huge roadblock. So what we recommend now and what we really try to do is anytime we're talking with a customer is try to get the security team in from day one, that very, very first meeting, right? Because the security team not only understand security, right? In order to be a good security professional, you've had to have knowledge and experience in just about something else, right? So they bring a lot of good operational thoughts to the discussion as well. But now they're part of the solution. We also recommend the security team being one of the first to go in the cloud, right? Get the security team to start figuring out how they can monitor, do incident response in the cloud. Once they figure that out, all the other doors open up so that if you want to do IoT or mission critical applications, they're going to be a partner with you moving to the cloud rather than a hindrance for you. Okay? And if you are one of the security professionals, hopefully you will see here today that what you can achieve within the cloud. And I only ask that you kind of be a little bit open-minded as you start diving deep. Right? We're okay if security says no, as long as it's because they truly understand and they still say it's a no. But what we don't like is a no because they don't understand. Okay? I thought this was a powerful statement from NASA. Right? Some of the most intelligent people in the world from all over the world, and they felt that we could do security better than they could do in their on-prem environment. Right? And if you think about what they do, a lot of it correlates to what you see in your environments today. And so my journey, I found that the cloud could not only be as secure, but I could actually achieve greater security and compliance in the cloud. I was able to improve my efficiencies in the cloud, all right? Save some money, or if it wasn't able to save money, I was able to achieve those things I was not able to do because I didn't have the money before. Right? So my savings now correlated to more capability somewhere else that I really needed. So with that, one other thing I'd like to let you know about is we have a program called AWS Educate. This is a free program for veterans, professors, teachers, and students. Okay? It's free online training, free credits for our services as you're learning. All right? We have a job board. So if if you're a student and you're looking to get a job afterwards, if you're an employer, okay, we got a lot of employers here. You're looking for fresh young talent in the DoD, right? You can post some of your jobs up to the job board to start getting people who have cloud experience, okay, and knowledge. So it's just awseducate.com/veterans. And so with that, I think I wrapped up rather early. Any questions? Happy to go in any level of detail you want to.
Don't let him off easy.
Yes?
So on one of the slides you had earlier, I saw that you had a cap between internet and cell towers.
The cap.
I know that you guys are cap in place on TCS. Is that similar to that you allow control access to cell towers using your cap cards? Or what does that mean?
So that cap is the DISA cap. It's not ours. We do have a couple of prototypes right now for a virtual clap in AWS. And that's being reviewed. There's a couple different ones that are being reviewed. I know of one that's getting a lot of attention, but it's got to go through a lot of wickets to get the approvals for that.
I think the other piece too, Mike, is that with the C2S regions, now secret's open and the top secret's been open, there is no cap, as we talk about cap in DoD.
Yeah.
That is purely a somewhat private community cloud region that is direct connected to gateways or servers.
Yeah.
But for GovCloud, because GovCloud does have connectivity to the internet, that was really the driver to require to have a cap between GovCloud and, let's say, the building.
Yeah.
I got to work with somebody that says, let's see if I can use that cap. Because now we're using our own case mechanism.
Well, there's the one in DISA, but there's also SSE LANT has one. Okay. Yeah. I think Transcom has got one. I know they're not Air Force, but kind of Air Force centric, but Transcom's got one. Yeah. Any other questions? Yes?
So you had a slide up there where you were talking about the security at the web level and DB database level, and then you said that the web servers are never connected to the DB. Well, so can you just briefly explain the security architecture? When you need your database to talk to your web server,
Yep.
can you go and just go into that a little bit? Yeah, that one. How do you?
Yep. So the reason why is that you have your application servers. So in a typical 3-tier web app, right? So this is based off of a standard 3-tier web app. If for some reason you only have a 2-tier app, then yeah, it would just go, it only have the 2 tiers, so they'd have to communicate. But typically, your web servers are only processing those web requests, maintaining the sessions, and they're passing the data to the app server, which is actually the server that's processing the data per the application, right? And then they're storing it down in the database. So they're the ones retrieving the data from the database to alter the data and then put it back down. So that's why the web server should never talk directly to the database server, because it's really only facilitating those communications with the client, maintaining the session, and getting the data down to the app server and then back out to the client, right? So this is where if a web server talks directly to the database server, it's been compromised and they're going straight after the data because they're bypassing all that processing that the application should be doing. Does that make sense?
Right, and then you're using your normal key management architecture to enable capabilities and communications between those layers.
Correct. Well, so the security group is kind of like a stateful firewall. So you have that capability there. But in addition to that, you also have the permissions of the services or roles. So one of the things in our IAM, so we have users and groups in our information and access management solution service. But we also have roles, okay? And roles start shifting, kind of taking things to the next level, all right? So with a role, you can give a user a role or a service a role, okay? And what will happen is when they go to request access, they'll inherit that role, okay? The nice thing about roles is that they're not static, or they don't have to be static, right? So right now, if you're an admin, if your user account is an admin, you have admin rights every time you want to use it, whenever you want to use it, right? With roles, you can start shifting that to like a just-in-time permissions, okay? So for our Amazon, some of the capabilities with roles is you have a user that is allowed to inherit a role, but when they go to check in, it may check their HR database. Is this person still employed? If they're going to GovCloud, is this person a U.S. citizen, right? Whatever the case is. So it can go across multiple data sources and do a just-in-time verification of that account before it actually allows access, before inheritance of the role, right? And so those roles is what you would use a lot with the servers communicating with each other. So it's not just, that's another aspect, because traditionally you would have a server. Now, if it's on the same domain, that's one thing. But if you don't really use the domains, it's all based off of network connectivity and what's being allowed. Now you have the roles where if a server doesn't have the role, it cannot communicate.
And I assume in roles you can set timers so that you want
Yes.
to access certain
Exactly. You can have it so they have to be within the U.S. that they are only certain times of day, right? So for like if you have like a help desk or a SOC, you might allow like 4 hours before shift, 4 hours after shift, and of course during the shift, right? So yeah, you can set up all kinds of parameters for that.
Can you also briefly speak to the direct connect service that you had on that slide?
Yep.
For the secure access. How far along is that? Is that a third-party provider providing that?
So you order that through us, and then we work with the ISPs to get you that private fiber between us and you.
Okay, and then there's obviously an encryption element. Is that done at another level?
You do that. So we provide a capability for you. It's up to you whether you want to encrypt that data. We highly recommend it, but it's still within your ability to encrypt. And you control the encryption keys. You control.
That you would provide the actual physical hardware for that encryption link, or if it's a classified connection?
There's a couple of different ways to do that. You could do. We don't have the ability to do like a TAC lane or anything like that, do we? I'm not familiar with it. Sorry? The connection on SIPR is a direct connection between SIPR and us on that one. Yep. Well, I'm talking about for the unclassified side. On that one's covered, but I'm thinking on the unclassified side. I don't know the answer on if we can do like a TAC lane or like that. But between our VPN services, you have a VPN Gateway that you can use, IPsec. There's different models for that. I'm not sure if we can support the hardware. I'll have to find out on that one for the commercial. Okay. Yep. Yes. Yes. So the question was, are these services available to allies and partners? Okay. So the top secret, and the GovCloud are not as a customer. Okay. But any of our commercial regions, U.S. East and West, are commercial regions around the globe. So we have in Asia Pac, we have a region in Japan, we have a region in Singapore, we have a region in India. You can use those. Now, on the GovCloud, you cannot be a customer of GovCloud. But if there's a U.S. organization, so like say within this area, is it APAN? APAN is on GovCloud, right? So APAN, if you're familiar with APAN, is on GovCloud, right? So a U.S. entity owns and maintains access to that, and they allow you to have access to that particular data in that application, okay? So if you have a U.S. sponsor that builds an application, they can give you access to that application if it's hosted on GovCloud, but you cannot be a customer of GovCloud. But you can be a customer of all the other commercial regions around the world.
And just generally speaking, what we're seeing now is the other partner nations and say coalition partners who do not have a GovCloud in their region in Singapore or Japan or Australia. The first question that we'll typically get is, hey, Amazon, when are you guys going to put a GovCloud in this other country? And generally speaking, the answer is that we probably never will.
Yep.
Right? GovCloud started back almost 8 years ago. It was a very different time when that was started. And today we actually have DoD customers who are questioning whether or not on the unclassified side, for things that would be considered, let's say, impact level 4, do they actually need to go to GovCloud for that? There's nothing that prevents them from doing it, but if you're from another country, let's say that you're Australia or Singapore or wherever it may be, you don't even have that option. So what you need to do is to challenge us to work with that member nation to determine whether or not they can host things that would be considered sensitive, FOUO, CUI, equivalent to impact level 4, in the region that is closest to them, or in many cases is in their country. That's where I spend a lot of my time in these other countries that do not have a GovCloud to help them understand how far can they go. The company Pegasus?
No, Pegasus, I know what he's talking about. Yeah. So that's, there are some interest, yeah, so there's some interest in getting the Five Eyes. So we're still working on getting DoD, into the IL6, because it started with the intelligence community. So there's some interest in trying to get Five Eyes, but that's not something we can do. That has to be something the U.S. government decides to allow. But I will say another thing. So GovCloud, like I said, started 8 years ago. Some of our leadership now, they will tell you that if we were asked to do a GovCloud today for the U.S., we wouldn't do it. Because at the end of the day, our regions are all managed the same, right? So we've gone through the FedRAMP process, and we got the FedRAMP High in GovCloud. But if you actually look at how our infrastructure is managed and the security, they're the same. Okay. And what we're also seeing is because GovCloud is more expensive, and it takes longer to get some of our services into GovCloud, we're seeing people who moved into GovCloud initially because they assumed they had to because it was government. They're actually moving out of GovCloud now into U.S. East and West commercial zones.
The primary difference is GovCloud was built when it was first done to meet ITAR compliance.
Yep.
That was the initial genesis of where and why it came about, which required us, our people that managed that region, that set of data centers, to be U.S. persons, both physical and logical access. We've actually upped it because of DoD's desire a number of years ago to be U.S. citizens.
Yep.
But at the end of the day, even if they're U.S. citizens, they're cleared U.S. citizens, they're cleared with a full scope poly, we don't trust them.
Yep.
And that goes back to what Mike had said. So there's a lot of that when we get into these deeper security discussions around, can I, in a Five Eyes country, utilize the commercial region in my country? Again, back to the original piece, because we don't have a GovCloud. So we'll go through and help folks understand that whether they are a U.S. person, U.S. citizen, cleared or not, that from an insider threat perspective, there really is no difference between the two.
Yep. And so, like what he said, we have a zero trust model, right? So my experience is once you're a domain admin, you had access to everything, right? So sometimes you might have an application admin that might be a little bit more narrow, but typically, in my experience in the Navy and in DC, once you had access to a lot. We have a zero trust model. The people who have access to the physical data centers have zero logical access. All they do is take the servers, prep them, install them, connect them, and that's it. The service teams are usually working in different cities. They don't know the physical location of the data centers. They have zero access to the data centers. Once it's up, they get the notice that the server's up and ready for them to prep. Then they prep it. They manage the services sitting on those servers. Okay. We have, because we were talking about the reduction of people who have access to data and privilege access, so our CISO every morning gets a report of everybody who had privilege access who executed that privilege access the day before. And he's able to digest that in 10, 15 minutes. All right, so if you look at our global infrastructure, we're not talking about one data center. Our global infrastructure, he's able to see that and say, okay, these 40 people gained access yesterday. They ran these commands. We also limit the types of commands. I'm going to highlight, we got time, but I want to, any other questions? I want to highlight something for you. So I say encrypt everything, right? So in a virtualized environment, where's the one place where you can never have encryption as of today? What? Memory, right? Basically on the computer as the data is being processed at that moment in time, right? At that moment in time, if somebody who had access to the hypervisor, they could do a memory dump of that server and just get whatever little data is being processed at that moment in time. Right? It doesn't give them access to the entire database or all the storage, but that one moment in time. Okay? So one of the things we've done is we build our own servers. We architect our own servers. We have, through our new Nitro compute service, our EC2, we've actually taken the hypervisor. It's no longer an operating system that you can SSH into and run or manage like an operating system. You can't do a memory dump. The hypervisor is actually taken out and is put into firmware, a separate security chip on the board, okay, that has a security boundary between that and the rest of the platform. So it goes through its checks to make sure nothing's been tampered with, nothing has been changed. But as it boots up, the hypervisor is in firmware now. The only way that a person who has the right credentials to manage is through APIs. Those APIs are all logged, right? And only certain commands are allowed, right? And so with that new Nitro chip for compute, we have completely removed the ability for a human to do any type of memory dump, right? So while technically that one moment in time, that one sliver of data could be accessed, we removed the ability for it to be accessed.
Again, that goes back to what I said earlier. That is assuming you have encrypted at rest,
Yep.
you're encrypted in motion.
Correct.
That
Yep. Yep.
or any insider access.
We've mitigated it the only way possible until they figure out how to do processing encrypted data. Yes?
Is that microchip your own development?
Yes. Yep.
And how long has that been deployed?
2 years now?
Started at least, it's gone through a number of series of iterations. Started about 3 years ago, and that's a chip that we found.
Yep.
And it's at all your data centers?
So it's not in all of our compute. So when you go through and look at all the different types of compute that you can procure or order, it's only a certain series, but they're annotated for that. So you can order GPUs, like if you're going to do artificial intelligence, machine learning, if you had some really powerful, you could order GPUs, your general processors. We have memory-intensive processing capabilities, but we have a couple different families that all have that Nitro chip, and they're annotated for that.
You think that there's hundreds of data centers, right? Each of them typically much larger than a DEC-sized data center that are around the world, millions of servers that are in there. So the Nitro hypervisor has started to come into the fleet, and over a period of time, we're not going to shut everything down tomorrow, that will become the standard across all compute instances in the fleet.
Yeah, let's continue to grow.
So I have one last question. So if I have a government customer, they want to use database services at just a NIPR level.
Mm-hmm.
Your explanation earlier, does that mean that they don't necessarily need to use GovCloud for that processing?
Mm.
The normal data center, and it'll meet whatever requirements?
Depends. If it's FedRAMP moderate, DoD IL level 2, then they can use US East and West.
Typically, if it's on NIPR today, right, it's not public internet, right? Today, for DoD SRG, that's going to be an impact level 4 or 5 system. Today's rules are that will need to be in GovCloud. We are now having the discussions around could there be some exceptions to that, as the civilian agencies have done. Let's just look at PII. The civilian agencies will host PII in Amazon's commercial region, let's say CONUS in East and West data centers. DoD today has taken a higher bar and said they'll only allow that in GovCloud. We're having discussions now to see if we can't start to make exceptions to that.
Yeah. Because at the end of the day, if that data is being trusted to go over an SSL connection over an ISP, and you encrypt it in AWS, what's the difference? There's no encrypted data is IL2 data. So it's just a matter of getting that concept that encrypted IL4 data is no longer IL4, right? It's IL2, it's gibberish. So it's just a matter of getting that, the same thing you do for the ISPs in the cloud. Any other questions? Yeah. So, I'll be around. I think the room's not going to be needed for a little bit. So I'll be around. I greatly appreciate your time today. Stop by the booth if you have questions. Hang around here if you have more questions. And have a great day. Thank you.